Alright, time for another LeetCode. And before we start today's LeetCode problem, I want to revisit a problem that I was doing yesterday. And I was doing 114 flattened binary tree to a linked list. Now, I was yesterday unable to fully understand what was going on and how to actually solve this problem. I got a comment on that video and they were telling me to think about this in the post-order traversal, and that might help you think about how you accomplish this problem. So first off, pre-order traversal. Now, pre-order means you process the node immediately when you arrive. So I'm going to start at the root and I'm going to process this root. So it's 1. Okay, then I go to the left. I go left and here's 2. So I immediately process 2. So we have 1, then 2, which corresponds to our output that we're hoping. So 1, 2. And then we go left again. Here, process this node. So we have 1, 2, and now 3. We just added 3. Then we come back up because 3 has no children. So we have to recurse. We break out of the recursion. And now we're back up 1 level. So then we have already processed 2. So we go down to its right child. So we've processed its left child, now we go to the right child. Now, immediately when we arrive to a new node, we process it. So now we have 4. So 1, 2, 3, and now 4. No children, so we pop back up. And then we pop back up. We've already processed this one. We've already done its left children. Now we have to go to the right child. So that's the next step in the recursion function. So 5 and then 6. So that's exactly what we see here. But the problem is that when we're doing this, we're needing to change the left and the right. If you see on the way that I was doing it, or I had to actually look at ChatGPT to figure this out. But the way that it was suggesting to do it was to go to you change the right and the left, and then you have to remember the previous. Okay, so how does this work when you're flipping the two children? So the way that we do it is the way that I'm thinking about this in the post order is now, okay, let's go through the post order, but instead of going through the post order normally, we have to make some changes. So let me show you the post order the way that it normally would happen. So so we start here and then we go left and then now process. So we process at the very end. Once we've done the left and the right, then we process the nodes. So 3 is the first one to be processed. Now, automatically you can see like, okay, there's something strange going on here. So then we come up and then we process the left. So we just processed the left. Now we have to process the right before we process this node. So we have to go right before we process. There we go. So we just went left. Now we need to go right. So we go right. Bam, bam. Now process, because on this node we've gone both left and right. So we process. So it's 1, 3, 2, and then we come back up here. We have to go right. So bam, bam. 6, 5, 1. Now you might be thinking like, okay, that has nothing to do with the output. That doesn't make any sense. Well, yes. But let's flip these trees. Let's flip all of the lefts to be rights. Okay? Now, what's going to happen is I can think about this by just doing, instead of going left first, I go right first. So the traversal is going to be like this, where we traverse right and then we traverse left. All right. So I'm going to start at the node, or at the root. Then I am going to go right. Do I process it? Nope. Because this is a post-order traversal. So I'm going to go right again. So right and then right. Now I'm going to try to go right. There's nothing. I'm going to try to go left. Nothing. Here, now I'm going to process it, which is exactly what we see here. Now I'm going to try to remember this node here, this 6 node. I need to have some way to recall it for when I pop back up, that I need to connect this, the next node to be processed, okay? And we're going to see that it actually aligns with this right here. So the next node to be processed, I need to remember and recall the old node that I was just at. So the way that that is accomplished is you have this previous pointer, and it's initialized as it's declared as a non-local, so you can remember this outside of the traverse function. So we just assign this 6 to be like, hey, remember this is the last node that we processed. Okay, so we just came here, we tried to go right, we tried to go left, then we processed it, now we remembered it. We said this is previous. Then we come back up here, we try to go left, there's nothing, so then we come back up. Now we've already gone right, we've already gone left, we need to process 5. Okay, so we process 5, we add the last known value that we just processed, which is 6, to its right, which is what we've done here. So we remember, we say, hey, okay, I was just processing 6. I was just processing 6. That's the one that I need to connect in this linked list. Okay, so we process this, then we come back up here. Do we do this one? Nope, because we also have to go left. So we've already gone right, now we have to go left. So we go left, and then we go right. So left and right. Why do we go right on this one? So on the number 1, we've already done the right calls. Now the only thing left, we come out of this and get back into this left call. So we go left, and now this 2 is a new one. So we come back up here, and now it's right. So now we have to go right. Okay, then here's the new one. We come here, we try to go right. There's nothing. We try to go left. There's also nothing. So, we're here. Let's process it. Now I have a question. Which one did we just assign previous to? We just processed which node? Which was the last node that we processed? It was 5. It was 5. And look at this. 6, 5, and now 4. Okay, so we can think of this right here as a post-order traversal of the flipped tree. So then we connect 4's right to be 5, okay? Then we pop back up here, then we still have to go left, so we go left. Here, we try to go right, nope. We try to go left, nope. So now we have to process 3. And what was the node that we had just previously processed? It was 4, right there. So 3, 4. Come up here, we process 2, then we process 1. Okay, there we go. So that's kind of how that question can make a little bit more sense. So thank you for commenting about that, and now let us get back to some depth first search. Okay, what should we do? Which problem? Kill process. Nested arrays. Let's do a randomized medium. So it looks like construct string from binary tree or add 1 row to tree. Let's see about this. All right, 6, 2, 3. Add 1 row to tree. Given the root of a binary tree and 2 integers, value and depth, add a row of nodes with value val at the given depth. Okay, so we're given a root, so we have a tree, and then we have a value that we need to add and a depth that we need to add it at. Add a row of nodes with value val at given depth. So maybe what this means is the entire, so let's say that depth is like 2. So the first layer, we don't do anything. The second layer, we also don't do anything. Or sorry, the first layer, we don't do anything. But then its children, so we're going to actually insert 2 nodes there. And then those 2 nodes will have the children of the original root node. So we're just like inserting a node into that location at depth 2, and then all of the children of the original node, we're just kind of like shifting down maybe. Okay, so the adding rule is given the integer depth for each not null tree node current at the depth -1, create 2 tree nodes with value val as current, left subtree root and right subtree root. Okay, I'm gonna have to reread that one a little bit because I'm not sure exactly what that one means. Curs original left subtree current's original left subtree should be the left subtree of the new left subtree's root. I think once I look at the example down below, I think things are going to start becoming a little bit more clear. I'm just trying to understand through the actual language, and then I'll look at the picture. But the pictures are always more insightful. Okay, so Kerr's original right subtree should be the right subtree of the new right subtree's root. So what I'm thinking that these sentences are describing is when I have my root, this root has 2 children, a left and a right. Now, the question is, when I add, let's just focus on the right subtree. So, or on the right child. So I have my root here and I have my right here. And by the way, the camera is flipped, so this is my right hand, but it appears as left. Anyways, so I have my root here and I have my right here. Now, this right is only one node, correct? Now, if I insert a node at this level, I need to bring this right node here down, okay, and now connect this new node to the right. But do I connect it as a right child or a left child of this new node? And I think what it's saying is you just continue with if it is part of the right or part of the left. So I have my root here. On the right child, I connect its one child to the right, and then on the left, I connect the new node's left child to be the previous child. I think that's what's being said right here. If depth equals 1, that means there is no depth -1 at all. Then create a tree node with value val as the new node of the whole tree, and the original tree is the new roots left subtree. Okay, so yeah, this is what I was trying to describe right here. So we want to insert at depth 2. So we have our root node, then we need to take this and we need to put a new node here. Okay, so we're inserting it at this level right here. So there's going to be a new node right here and a new node right here. And then do we need to connect this new node's right or left? We need to connect its left here because this is the left child. Then we're inserting right here, which is right there. And do we connect its left or right child? We connect its right child because this is the right subtree. And then all of the other values stay the same. So we have 6, 5, and 2, 3, 1. Okay. So here's just another example. 4, 2, and then this 2, we're creating a node here and a node here. Okay. So trying to think about how to accomplish this one. We'll need some way to keep track of depth. Okay. I was thinking possibly doing so there's like a level order traversal where you traverse level by level. And if I'm able to do that, possibly I can just insert an entire level. But then when I'm doing that, I might lose track of the node's children, and I think that might cause some complications. The way that I'm now thinking about doing this is just continuing to do a depth first search. Okay, so I'm going to go and traverse it pre-order and try to keep track of the depth. So I'm going to come here, and this is going to be depth equals 1. So equals 1. So I just start off with depth equals 1. And then every time I recurse down, I add 1. So now depth equals 2. And then I'll have to check if depth is equal to the current depth. Current depth. There we go. So I'll check if current depth is equal to desired depth, which is here, so just depth. And then if it is, I will process accordingly. I will also need some way of determining was I a left child or a right child. Unless I look ahead somehow. Maybe I don't judge it based off of my current level, but the level below me. So what I mean by this is I come here and I'm at depth of 1. But then I say, okay, the desired depth, so current depth is 1. Desired depth is 2. So I want to insert at level 2. So desired minus 1 equals 1. So now I'm at this 4, and I say, okay, I know I need to insert 1 layer below me. Okay? Does that help me? Okay, another way that I could keep track of this is kind of like this. So I have node, and then I have left child, or is left child. So on this, I can keep track of if I was a left child or a right child based off of this kind of like Boolean value that I will pass in myself each time I call the traverse function. Okay, so that's actually a way that I can keep track of if I'm a left or right child. I have a way to determine the depth that I'm at. The other thing that I want to consider is I'm actually changing the depth while I'm coming in and out of things. Or not coming in and out of things, I mean inserting something in. So I'm going to be inserting a layer, and that actually changes the depth. Is there some tricky business that's going to be coming when I'm going down? I'm increasing the depth, and then I am coming back up, and then I'm inserting something. So now the depth, so for example, I come here, so depth is 1, then 2. Now I add an extra row here. So I have 1, 2, 3, 4, kind of like this. 1, 2, 3, 4. Now I'm going to pop back up, and so I want to pop up, and it's going to be, so 4. Now I'm at layer 3, right? Then I'm at layer 2 again, which is consistent with both of these are layer 2. Yeah, that is consistent. What I was worried about is would it have been the case that I'm coming up here, I'm adding something, a node, and I don't take that into consideration when I'm incrementing the depth or decrementing the depth, and then I get to some weird thing where this layer is no longer layer 1, it's layer 0. Or if we had the values not increment correctly. So that's what I was thinking, but it looks like actually it would work. So I have to come here, depth is 1, then depth is 2, so I insert. Now depth, I come here, depth is 3, then I come here, depth is 4, then I pop back up, depth is 3, depth is 2, depth is 3, depth is 4, depth is 3, is 2, is 1. Okay, so I think that is working. Now for the fun part of actually implementing it in code, so more coffee. All right, so what is our base case? Is if we are a null node. So I guess the other question is, do we want to process it pre-order, post-order, or in order? I don't see a problem necessarily with processing it pre-order, right? I'm coming here, and then I'm coming here, and now I know that I need to change this one. So I need to insert this one. So then I add a node here. So I add a random node here. I'm just going to say a random node here. And then I connect 3 to this random node. And then I connect this random node to my current nodes left. And then I traverse. And then I can do the same thing here. And then I traverse here. So process in this case would be the logic for, hey, I'm at this depth. Let me insert my values. And then, so then when I pop back up, I'm not going to reprocess the node because I've already done it. So pre-order traversal, process the node immediately. Okay. So base cases, if not node, return. Okay. Now process node. So if so I'm declaring this as a non-local so that I have access to it outside of this traverse function, so I can change it, manipulate it, etc. So now I need to process the node. So if current depth equals to this depth, and do we want to increment the depth immediately, right? So I pass in this. I guess it's more of a question of preference, because we could either we could increment it in the function, or we could increment it when we call the function. So when we do the recursive call. Oh no, actually we can't do that because we're doing a non-local. So just in this implementation that I did, I think I actually have to do it this way. Current depth plus equals 1. And so what I was thinking about doing is saying, like, whatever, traverse, and then node, and then is right will be like true or something if we're going on the right direction, and then current depth plus 1, but I didn't add a current depth here, and I'm utilizing current depth as an external variable outside of the function. So that's what I meant by, in my current implementation, I don't have that set up. So that's why I have to increment when I get to the node. Okay. Okay, so if we've reached the depth, so we're gonna come here. This is layer 1. So we start off at 0, then we go to layer 1. So current depth is 1. So it's not equal. Then we have to go down. It's going to increment. Current depth is now going to be 2. So now we need to process we need to, I don't like to use the word process because we have to process every node in the tree, but the process algorithm, or nah, not algorithm, but the process, each time we do a tree traversal, we have to process all of the nodes. And it's kind of up to us to determine what process means. Sometimes it just means print the value to the screen. Sometimes it means add it to a linked list, like at the previous video that I was just doing. In this case, process means we need to check if the depth is equal to what our target. And if so, then we need to do the logic of rearranging the children. If it's not, then we leave it. So that's process means check. Okay. So if the check is triggered, so the depth is equal to what we want, now we have to, I'm just going to say rearrange. So, and I'm just pass for now. So we come here, and then we come here, right? And no, we come here to this random node, and then we go to 3, then we pop back up. How do I capture that? I guess it should be, I have to traverse left, or no dot left, then true, because it is the left child. So we're going to go down, down, try to come here, try to come here. Then I need to decrement the current depth minus equals 1. I decrement the current depth, then I go right, so traverse node dot right, and now right, the node that I'm passing in is not the right child, so, or is not the left child, so it's false. Then I try to go left, I try to go right, then I pop up, and I need to decrement current depth again. Correct? I guess I'm a little bit hesitant on this because I increment current depth by 1 once in this singular function, but I decrement the value by 1 twice. So just my gut feeling is going to be that's not right, that I'm decrementing twice. I'm calling this function a fixed number of times for any node. So that's kind of the O of n, right? How many times am I calling this function? It's n times, where n is the number of nodes. Now, that n is fixed. It will come out to be some number. It's 5. So I'm calling this function 5 times. And each time I call this function, I increment by 1, and I decrement by 2. So now I have -1. But when I'm talking through it with going through the pictures, I physically say increment here, decrement here. So there's some kind of, there's a, okay, so increment. Okay, I'm at 1, now I increment to 2. Increment, I'm at 3. Now this one, I don't increment. One, and then 2, so it comes here. I start at 0, and come here, and then I add, I'm at depth 1, so I hit this. Then I check, it's not, so then I come here to the left. Now I'm at this node. This node will increment current depth by 1. Okay, so I'm now 1. Or sorry, I'm now 2. Then I come here and I increment by 1. So now I'm 3. Yes. Yeah, this has to be wrong. The code that I wrote. So once I come to 3, I don't want to go left and then increment myself to 2 and then go right, then, or sorry, I don't want to be at 3, so this is currently number 3. I don't want to attempt to go left. I can't go left, so I decrement my own layer, and then I go right, and then decrement my layer again. So that would be 1, 2, 3. So my current level is at 3, and then 2, my current level is 2, 1, current level is 1, and then I'm here. See, all of a sudden, this is level 1. This isn't level 1. What I want to do, I think, is something like this, where I come here. I come here, so I add. So I'm 1, 2, 3. I try to come here. I try to come here. Then I decrement. Now I'm 2. Okay. Then I come here. Now I'm 3 again. That's correct. I try to go here. I try to go here. Nope. So now I decrement. So now I'm 2. Yep. Yes, I am. Then I decrement again. I'm 1. Yes, I am. I try to go right. Then I decrement again, and I'm off the tree, essentially, because I just processed the root node. So I think this implementation right here is the accurate one. Okay, now let's get back to this rearranging. business. So how do I want to, if I'm going to be manipulating the children that the current node is associated with. So I'm currently at 2 and I want to insert this node here. Do you remember in linked lists you have to have kind of like a temp variable to make sure that you don't lose the next pointer? That's kind of the way that you can think about this as kind of a linked list. So here is current and here is current.next. Now I want to insert into the linked list this one node, and this node has a pointer to next. That's kind of the way that I'm gonna have to do it, is think about this as a linked list. And in linked list, what you did was you have this node here. So you have a node here, then you create the node that you want to insert, okay? And then what you have to do is you have to have this as a temp variable. And then what you can do is you have access to your left child. So then you assign this this temp's value to point to this 3, because right now you have access to it because it is your left child. So now there's 2 things pointing to number 3. Your value left, so current left is 3, and temp left is 3. Now, because you have access to this temp variable, so 2 things are pointing at 3, you can actually delete this connection, because you can still access this 3 variable, or this 3 node, from the temp. You've connected that. If I just said, like, the problem is, if I just said, like, current, which is this 2 node, current.left equals new node. Well, this new node doesn't have a left or a right child, and now I just lost all my connection to this 3 because I just changed my left pointer to be equal to this new node up here, which is going to be the 1. So I don't have this connection here. So what I need to do is take my new node and have its next pointer point to this 3. So I need to connect this node's left child to be 3. Then, all of a sudden, my current node's left is pointed to 3, and my temp or inserted node left child is also pointing to 3. So right now this connection I haven't done. It is connected to 3, just as this is connected to 3. This one is also connected to 3. My temp is also connected to 3. So then the last step is, because I have access to this, now I can break this connection and just assign this connection. Does that make sense? So the way that I'm going to do this is like temp equals, and now I need to figure out if I am looking at the left or the right. So if is left child else, okay, so this is the child case. Now let's implement left child. So temp node I think I will need to initialize a node. So equals tree node. So right now what I'm doing is, let me make myself a little bit smaller. I am this node right here. This is what I need to insert, but it doesn't exist right now. So I need to instantiate it. So they give us a definition of a tree node right here. So I am just accessing this constructor method, and so it takes in a value, which we have here. So tree node is val, and then it takes in left child and a right child. So they're defaulted to none, which is fine. That's okay, because my next step is going to be to connect them. I could connect them kind of in this constructor right here, but I'm just not going to. I'm just going to declare it like this because it's a little bit clearer to see what I'm doing if I do things very systematically. Okay, so I just created a temp node. Okay, so I created this random variable, or this random node up here. I want to connect this random variable's left because I'm the left child. So I want to connect the random variable's left to be equal to this right here. So temp node dot left equals the current node dot left. Okay, now two things point to this 3, so it's this case right here. So now I can break this connection and create this connection. So node dot left equals temp node. I think that's correct. Okay, so now we have to do the case if it's the right child. I don't think so. Do I need this left child? Because I'm changing the child of my current depth. No, I don't think I don't think I actually need left child, or is left child, because once I'm at this current depth, I see, okay, I do want to, okay, there was a mistake, I think. I think what I need to do is, if the current depth minus 1 is equal to the depth, then I need to insert below it. Okay, so what this changes, let's say that I want to insert here at layer 2, at depth 2. I start at 1, and then I say, okay, I'm at 1 right now. I know that I need to insert right below me, because below me is going to be layer 2, right? This is layer 2 right now, but I need to insert below me. Yes. So I have myself a left and a right. I can just connect those because I know if it's my left or my right. I don't need to check, like, I don't need to go down here and then say, oh, I was actually a left child, so I'm going to connect myself up. That doesn't make any sense. So this section is connect left. Okay. Now we're going to have a connect right. Okay. So now I need to connect the right node. So temp node equals tree node of val. So this is going to be a new variable, or a new node. I'm instantiating a new node because you see here we have 2 new nodes. So I'm calling the constructor again using the val because we want the same value for that for both nodes. So now this temp node, I am creating a new node right there. I could do it like temp node 2 just to make it a little bit more clear that this one is not the same as this one. Okay, so what do I want to do? I want to create a random node out here. Accomplished. Then I want to connect this random node out here's right child to be equal to, random node out here equal to 6. So temp node 2 dot right equals my current node dot right. So now I'm at 4. I determined that the layer below me is the layer at which I need to insert. So now I created this random node. I took this random node and assigned it equal to my current node's right child. So now this is connected, and my random node right child is also connected to 6. So I have 2 pointers to 6. So now I can safely break this connection and point my current right's child equal to this temporary variable, this random node up here. So now what I can do is node, so my current node's right child is equal to temp node 2, like that. So now I have processed it. And I said that I no longer need this is left is right. So I'm just going to get rid of that and get rid of this up here. So now I am, let's see, going to call the function and see if we get the right answer. So traverse of root. And now it said that if depth equals 1, that means that there is no such depth. Then create a tree with let's see if the constraints is that the depth of the tree is 1 to a big number. So if depth equals 1, that means that there is no depth at all. Then create a tree with value val. So if I automatically, or if I do, so current depth, let's see. So current depth is 1. So it's going to start at 1 and then increment. So I think actually I start at 0 and then I call this and it is 1. And in the case where the desired depth is 1, if depth equals 1, that means there is no depth at all. Then create a tree node with value val as the new root. Okay, so if depth equals 1, then root equals tree node val, like that, and then return. Otherwise, just do the root. Should we submit it? Let's see. Zero out of 100. Okay. Do I need to like return root? Is that what's going on? Well, I did need to return root, but I didn't get the right answer, so why? Okay, so my coffee is out too. Darn. Okay, so I have this current depth. Is there maybe a problem with my depth? So I start here, I increment by 1, and then I see if the value below me wouldn't it be the value below me is equal to depth, like that? Because depth is going to be 1 below, so the depth is going to be higher. Wouldn't it be like that? So I have 1, and then I look. Oh. Was it accepted? Was it not accepted? Got my hopes up. It passed the test cases here, but failed on submission. Got my hopes up. I was like, I'm gonna get it. No. But we did pass 100 out of 109 of the test cases. Value depth equals 1. Output is, oh, okay, so I just need to return root. That was that problem that okay, so, and then I can simplify this even further. I can make that more elegant, just like this. So return tree node like that. Okay. Depth equals 1, output equals that. Isn't that what we're supposed to be doing? It's expecting this? That's not in accordance with what the description said. If depth equals 1, that means there is no depth minus 1 at all. Then, but there is, right? That the one that we just got wrong, there was a depth minus 1. So I think this point is actually incorrect right here. Then create a tree node with value as val as the new root of the whole tree. And the original tree is the root's left subtree. Okay, so in this case, maybe I'm just reading this question incorrectly. So, new root equals temp tree, or tree node. Okay, so now I am going to have to do new root dot, what does it want? Left? Is the new root's left subtree. So new root dot left equals my current root. Okay, and then I need to return root. And the original tree is the new root's left subtree. Does that conform with kind of what we're seeing here? So 1 is connected to 4, which was the previous root. Okay. I must have misunderstood or misread this, because that means there is no depth minus 1. I thought that it meant, okay, in the case that we say depth equals 1, there is no subtree. So just don't bother. Just return, just create a new root, and that's your answer. But apparently I read that wrong. Still on this one. We still on the... Oh, of course. Of course. Because we're not returning root, we're returning this new root. Right? We're updating the tree such that this is now the root. So we need to return root, not old root, obviously. And there we go. We got it. We got it. Oh, okay. Okay. There we go. After much toil, it was a long adventure. We encountered many obstacles along the way, and we finally made our adventure through the dark forest of problem number 623. It was a long journey, dark, perilous forest, but we succeeded. We succeeded. We got it. Okay. Thank you guys so much for watching this video. If you want, subscribe. That would be awesome. I am going to continue to make new LeetCode videos every day. Put out more and more and more LeetCode. Keep practicing. Keep moving forward. Keep getting better at this. bring you guys along for the journey, show kind of the thought process of how I'm trying to solve problems, and give a realistic kind of understanding of, or a realistic example of what it's like going through LeetCode and problems that I've never seen before. Not just someone who already knows how to solve everything and they're just kind of like telling you the answer or something. It's someone who doesn't really know what they're doing. They're just trying and moving forward. And eventually, I think I will be able to start, hopefully, the idea is in the future things will be able to progress a lot faster. And uh, yeah, so if that is something interesting, subscribe to this channel, and I will see you guys. Actually, not even tomorrow. I'm gonna make a new video almost immediately because I feel inspired, and it's Sunday today, so perfect time to do extra leak coding. So there we go. Anyways, I will see you guys later.